Picture this: the world's most advanced AI models, programs that help doctors diagnose diseases, automate industrial processes, or simply make your search results better, are demanding an unprecedented amount of energy. Behind every AI model, from Google's Bard to OpenAI's GPT series, lies a vast network of data centers consuming staggering amounts of electricity. These centers, often referred to as the brains behind AI, are equipped with thousands of GPUs, graphics processing units, and TPUs, tensor processing units, that train and process machine learning models. This computational demand is immense, requiring vast amounts of electricity 24/7. Despite the tech industry's efforts to shift toward renewable energy sources, the global energy grid is still heavily reliant on coal, natural gas, and oil. Without direct sourcing from renewables, the carbon footprint of such training processes becomes a significant environmental concern. But as we push to power AI with greener sources, a surprising player has stepped into the spotlight: nuclear power. Could nuclear energy be the answer? Will it bring more risks than rewards? Time will tell, but for now, let's get into it. The energy needed to support AI models today is so massive that it's now the primary bottleneck in their development. Just a year ago, the main limitation for training AI models was computing power, but that's being quickly solved with advancements like Google's Willow quantum AI chip. Check out our channel if you'd like to learn about that one. But as AI technologies continue to advance, the industry is facing an energy crisis of sorts. In fact, a report from Latitude Media explains that the rise of AI has led companies to re-evaluate how they power their data centers, which is why we decided to make this video. Tech giants are realizing that it's not just about having enough processors or servers, but finding sustainable, scalable ways to power them long-term. This issue isn't limited to just one or two companies. Google, Microsoft, and Amazon are all facing the same challenge: keeping up with the energy demands without compromising environmental goals. These data centers, which house thousands of servers that run AI models, are some of the most energy-intensive facilities on the planet. It's even more evident with Amazon's recent move to purchase a data center near the Susquehanna Nuclear Power Plant in Berwick, Pennsylvania, for a cool $650 million, starting to display a trend that even newer companies like Oklo can join in on. IPO'd in 2021, Oklo is a compact nuclear reactor play aimed at providing clear, sustainable energy. They've received support from the likes of Sam Altman as well. So it's becoming unsurprising that other big players who use vast amounts of power are fueling this push. Google's partnership with Kairos Power, a startup developing small modular reactors, SMRs, to sustainably meet the needs of AI workloads, is another example of how the industry is responding. This partnership, expected to bring the first reactor online by 2030, highlights how critical nuclear energy could become for the tech world. But the question remains, why nuclear? As Google's Senior Director of Energy and Climate, Michael Terrell, noted, the traditional grid isn't equipped to support AI's explosive growth. In his words, the partnership with Kairos Power aims to accelerate clean, reliable nuclear power and allow AI to reach its full potential without draining the world's energy resources. According to a recent article done by CNBC, pulled from the US Department of Energy, global electricity use could rise by 75% by 2050, with the tech industry's AI ambitious driving much of the surge. This could become the most efficient way to ramp up power supply to meet demand without spewing mass amounts of CO2 into the atmosphere, worsening the already fragile global warming situation and causing extensive weather abnormalities. All in all, the shift to nuclear energy is not without its controversies, and concerns are already surfacing about the safety and environmental impact of this choice. Small modular reactors, or SMRs, are smaller and more flexible than traditional nuclear reactors, which allows them to be integrated more easily into the grid, and specifically in tech-dense areas. Unlike traditional nuclear reactors, which are massive in size and require extensive infrastructure, SMRs are compact and modular by design. This smaller footprint allows them to be built off-site and transported to their destination, significantly reducing construction times and costs. These SMRs produce less waste and are generally considered safer than large reactors, largely because their designs include automated shutdown systems and lower risks of overheating. Unlike traditional reactors, which generate power on a scale that might overwhelm smaller grids, SMRs can also scale output based on demand. This is particularly useful in areas with high and fluctuating energy needs, such as tech hubs, with data centers running energy-intensive AI workloads. This also makes dealing with errors more manageable, since they are on such a smaller scale. Some SMRs are even designed for underground deployment, providing additional protection against external threats like natural disasters or sabotage. Yet, nuclear power is a delicate topic for many. As we've seen with catastrophic events like Chernobyl and Fukushima, the consequences of a nuclear accident are severe. Critics argue that as more companies like Google jump into the nuclear sphere, the risk of such incidents could rise. However, SMRs have been designed specifically to minimize these risks, and according to Kairos Power, they are engineered with layers of safety and oversight that make an incident highly unlikely. Environmental groups also weigh in on this debate. While nuclear power produces zero emissions during operation, it still requires uranium mining and produces radioactive waste, which has to be stored securely for thousands of years. Mining operations disturb ecosystems, produce large amounts of waste rock, and in some cases expose nearby communities to radioactive material. The energy-intensive nature of mining and processing uranium also contributes to greenhouse gas emissions, albeit much lower than those associated with fossil fuel extraction. According to studies, the life cycle emissions of nuclear power, factoring in uranium mining, plant construction and decommissioning, are comparable to those of wind and solar energy. By contrast, fossil fuels release vast quantities of CO2 and other pollutants during combustion, driving climate change and causing health issues. To put it into perspective, coal emits roughly 820 grams of CO2 per kilowatt hour of electricity. Natural gas emits about 490 grams of CO2 per kilowatt hour. Nuclear energy, on the other hand, contributes around 12 grams of CO2 per kilowatt hour across its life cycle, which, even if you don't understand what that actually means, is clearly less output, resulting in a noticeably lesser impact in the short term. Long term. As said earlier, nuclear energy generates waste, which is inevitably radioactive, a scarring word for most. And with small nuclear reactors, or SMRs, you'd expect them to create less waste, right? I mean, they're small after all, why would there be more? Surprisingly, according to a study done by Stanford, SMRs generate more nuclear waste. Quote, "Our results show that most small modular reactor designs will actually increase the volume of nuclear waste in need of management and disposal by factors of 2 to 30 for the reactors in our case study," said study lead Lindsay Kroll, a former MacArthur postdoctoral fellow at Stanford University's Center for International Security and Cooperation, an unsettling thought as this technology becomes more mainstream. One thing to remember is that these reactors are still in their infancy. It's like worrying if a car will drive far someday. While you're looking at the Ford Model T, this is going to take time. The more that's invested into the space, the more research will be done and improvements made that could result in lower waste or potentially a way to recycle the waste in some way. That's reaching, but it's something we'll have to wait to see. As one article in Vanek's blog noted, AI could unlock the full potential of nuclear power, by making it easier to monitor and manage nuclear facilities, thus addressing some of these safety concerns. This suggests that with advanced oversight, the use of nuclear energy could help reduce our carbon footprint considerably. But what does this nuclear shift mean for the future of power companies? As tech giants like Google and Amazon invest in nuclear energy to power their AI operations, it could spark a shift in the traditional energy sector. Utility companies have long been the primary players in electricity generation, but this new demand may open doors for private, tech-driven energy ventures. In fact, Latitude Media reported that AI's energy needs are already leading to new dynamics in the energy market, with tech companies making unprecedented investments to secure power for their data centers, like Google's partnership with Kairos Power, as mentioned earlier. This trend might mean that future energy production could become highly diversified, with tech companies themselves possibly owning and operating their power plants. Unlike traditional utility companies, which cater to a broad customer base, tech firms can tailor energy solutions to their operational demands, optimizing efficiency and cost-effectiveness. As more firms invest in SMRs, we may even see public companies emerging that specialize solely in providing nuclear power for AI, further decentralizing the energy grid. This trend could give rise to a new class of private energy providers focusing on serving high-demand industries like AI, cloud computing, and advanced manufacturing. On top of that, it could spur a market boom in nuclear energy, making it possible for investors to get involved in nuclear companies focused specifically on AI support, a development that could reshape the entire energy trade. It's like investing in a real estate trust stock that owned dozens of warehouses before the big e-commerce boom that fueled much of Amazon's rise. If nuclear power does prove itself as the fuel of choice for AI, there could be trillions of dollars at stake. TechRadar reports that the energy deficit caused by AI demand is expected to hit the tech industry as soon as 2026. The AI industry's energy needs are immense, requiring consistent, large-scale power to support the operation of advanced models. And these needs aren't just a temporary spike. They are expected to grow exponentially as AI applications become more embedded in everyday technologies and enterprise solutions. As tech companies and startups invest in nuclear energy infrastructure, the industry could generate new revenue streams, increase the value of energy contracts, and drive innovation in both energy generation and AI adoption. For traditional power companies, this shift could be a double-edged sword. Power companies that aren't ready to meet this demand might lose significant revenue, opening the door for tech firms and new nuclear energy startups to take control of the market. This shift is already evident as companies like Google and Microsoft pour resources into securing their own power sources. Startups focused on nuclear innovation are poised to disrupt the market further. By leveraging advanced technologies and government incentives for clean energy, these companies can operate with agility and deliver solutions tailored to tech-dense areas. The rise of such ventures could accelerate the adoption of nuclear power and erode the dominance of traditional utilities, leading to a more fragmented yet competitive energy landscape. As we move forward, one thing is clear: the future of AI and nuclear power is intertwined. From small modular reactors to decentralized power production, the rise of nuclear energy as a solution to the AI power demand represents a significant evolution in both the tech and energy industries, as long as bold projects like these can be safely controlled. Whether this will lead to a cleaner, safer future or an era of new risks depends on how well we balance innovation with responsibility. The question now is, will nuclear power pave the way for the next generation of AI, or will it bring with it a new set of challenges that we haven't yet anticipated? Whatever the outcome, it's a story worth following. After all, the choices we make today will shape the world of tomorrow. Thanks for watching.